My name is Jeff McWhorter, and I'm the lead developer of RAMADDA, an open source science data repository. RAMADDA provides a rich suite of services around data management and visualization. As part of my submission to the ASDI challenge, I've used Amazon's S3 Java SDK to add functionality to RAMADDA that allows for the integration of arbitrary S3 data collections into a RAMADDA repository. To achieve the UN sustainability goals, I believe that it's critical for user communities and stakeholders to be able to create, share, discover, interact with, and understand the data that underpins the many problems that they face. Implicitly, if we can facilitate these needs, then we are advancing progress towards meeting the sustainability challenges. My contributions in this are twofold. As we see, I've built a number of example interfaces to ASDI datasets that serve to address these data access challenges, that is, making data easier to use. The second contribution is the underlying software infrastructure that I've built that enables other tool builders, even non-technical users, to develop better interfaces to their data. Being open source, RAMADDA and its S3 integration component can be easily run and made use of by these external communities. Well, let's look at RAMADDA S3 in action. Here's an example ASDI dataset, NextRad radar data on AWS. We'll navigate down to the resources on AWS section, copy the S3 URL. Now we'll go over to RAMADDA. So RAMADDA is also a content management system. The end user can simply go in, say create a new AWS S3 entry, enter the S3 URL, give it a name, NextRad example. There are a number of other configuration options. We'll skip over those for now. And simply hit Add AWS S3. RAMADDA uses Amazon's Java SDK to query information about this S3 bucket store and provides this default browse interface to the data. One can navigate down through the year, month, and day folders to view a list of stations, and then one can look at a particular station and then a particular data file. Well, there's not a lot of added value here. For the sake of time, we'll skip over some configuration steps in RAMADDA, but they're all thoroughly documented in RAMADDA's user guide, and we'll see the end result. Here now, RAMADDA can extract out spatial and temporal metadata and present that to the user. Again, we can navigate down through this year, month, and day space. But this time the stations are shown on a map. The end user can simply go in and click on an entry in that map to view the list of data files. RAMADDA provides a number of services. For example, here there's a RSS feed or a JSON listing of this content or a threads catalog, and these allow external programs to access this information. One can drill down and look at a particular file. Notice then RAMADDA recognizes this file as a level 2 radar data file. RAMADDA has knowledge of a large number of data types, and it's easy to provide new data types through RAMADDA's plugin facility. There are also a number of other services, so if one is so inclined, one can look at the low-level metadata of that file or access that file remotely through a service such as OpenDAP. So real quickly, we'll just show some examples that we've put together. I invite you all to explore. This is all online. These are all examples we put together mostly interactively using RAMADDA's built-in wiki visualization and mapping capabilities. First is this flood risk data. This interface, the end user can come in and view a particular state and then look at the details, the county level details for that state. No code was used to create this. Second is the NOAA Integrated Surface Database. This is a large collection of observation data dating back more than 100 years. One can view a particular year and then using the built-in search capabilities, search for, in this case, Denver, and then view the data for Denver. This charting and mapping again were produced using RAMADDA's wiki capabilities. The African Soil Information Service, they provided a data file which had the sampling locations for this data. We put together this color-coded map that allows a user to query the data interactively. And then the user can simply go in and say, I'm going to grab all that data. And then finally, global fisheries data. This was a 1,000,000-line long, very large CSV file, very cumbersome to use. We use RAMADDA's built-in ETL capabilities to clean up the data, generate a schema for that data, and then this provides, there's a built-in search facilities for that data. Well, that's all we have time for. Please explore. Thank you for your time.